All right, hi everybody. Today we are going to be exploring the plugin for Human Tools. This is a fantastic plugin for Grasshopper with a lot of visualization components. It was developed by this guy, Andrew Human, who is a frustratingly brilliant computational designer, very young. He's like 27 or 28 or something. You should check out his website. He's got a bunch of plugins that he's done. So this is the one we're going to be using, Human, but also all of these others. I haven't even had time to understand all of them, but they are fantastic, very creative. He also does a lot of computational art. He's definitely somebody, if you want to get deeper into computation, you should know about Andrew Human. So the first one we're going to do, and again, you should have all of these scripts. So this is more of a follow-along tutorial. You can start. We'll just bake out this tower so that we can see it. And what we're going to do is do some simple dashboarding. And this is sort of the absolute simplest version of it, where we're just going to cut some floor plans and cycle through them like this. Blah, blah, blah. So this is a way to basically just build some custom notation on top of your analysis. So what we've done here is very simply we've created our floor plans by creating a series of cuts with this brep plane or brep plane intersection. So this is under your intersection tab, under mathematical, somewhere in here, brep plane. So all we've done is created a series of heights. So you can look at these guys here. So starting at 0, which would be your first floor, and moving up. It doesn't really matter how many of these you have. We could create a whole bunch. And that way, you know, if your building is changing heights, you can be guaranteed as long as it is below this maximum height, you will always cut a floor plan through it. And so you're just creating a point at 0, 0. The point does not need to intersect your tower. It's just a point in space, a variety of heights, and then we are moving that point up in space. And so you can see the z value here, the z coordinate for the point is the same as those heights because we've created this little z factor here for the movement vector. This guy is red, but that is just because the planes that are higher, the heights that are higher than the actual tower, will create these. Oh, well, we flattened it here, so let's unflatten it. So basically, we have heights up to this 30th value. And after that, all of the planes are missing the tower, so they're up here. And that's why this is turning red. So that's okay for the purposes of this tutorial. We're just concerned with the heights that do intersect the tower. So we've solved here for those sectional cuts. And we are just looking at one at a time. So we are just toggling through. So the visualization component is really simple. So if we just turn off all of these guys, this is just a list. This is just a list of cuts. We're finding one at a time, dun, 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 like so. And we are using this component, which is preview line weight. And that is from Human Tools under the display tab. There's a whole bunch of great stuff, and we'll go through some others as we start to build up a dashboard. But this most basic one just lets you take a curve and give it a color and a thickness. So we can have this be really thin or super thick, whatever we want. I think 4 or 5 looks pretty nice. And so we've also, just to create a little bit more information or analysis, we have taken that curve and we have come down here and found the area, and we are going to use this guy here, which is screen-oriented text, and we are going to display the area of that floor. So screen-oriented text accepts text, which is this guy here, the area. It needs a font, so we've used Garamond Bold. Garamond's actually probably a bad choice. Serifs are beautiful and nice, but they are not really made for, it's more of like a print font. They're not as good for displaying on screen. So Arial, not the most sophisticated font, but gets the job done, looks pretty. You can set a justification here, so that doesn't really matter. Let's use maybe, yeah, middle left works well. And you can set a size here. So now, as we scroll through our floors, we can see we have these larger areas at the base going up to smaller areas towards the top. So the other thing that we need to do for this text is we need a location, which is just a point. So what we've done is taken, if we, let's hide everything for the moment, we'll even hide our geometry. So we have a curve, and we're going to use this discontinuity component. This is just a base Grasshopper component that'll give us 4 points. I have already sort of found that if we pull out a point, for this particular view, point number 2 looks good. That's what we want to tag our text to. But we found that if we show this and show this guy, if we just use that point as the location, the text is sort of hidden behind the building. So we've just made a simple little vector that goes from the 0 point over here to the second point over here, and that's what this vector 2 point does. And then the amplitude component, again, this is all base Grasshopper. This is under, apologies, where are we? Control Alt, under vectors. This is all the stuff we're using in here. Amplitude just lets us take that vector, take the direction of that vector and specify an amplitude. And so this is just going to move our point here. It's just going to move it away from point number 2. Well, from point number 2 away from point number 0 out into space, like so. And so that's just a way of, if we use that point for the location, it's just a way of fine-tuning the visualization. You always want to push the visualization just a little bit so that it's nice and clear and legible. And now we have a very simple sort of annotated display of individual floor plans in our sort of pyramidal building and the associated area. So super simple, right? Nice, simple, easy. Again, preview custom line weights and screen-oriented text. So let's get a little bit more ambitious. Good Lord. Okay, so down here, now we're going to build a dashboard. So here we have not 1, but 2 B-reps. My God. We are doing the exact same thing. We are cutting sections through them. You will notice that we have grafted the towers or the buildings, and that's because we want these planes that we've specified with our points, which are moving up in space. We want each tower individually to intersect every single plane that we've defined. So if we do not graft this, you'll see that this first tower is going to get greedy and it's going to try to intersect with all of them, and there's nothing left for the second tower. So if we graft them, then each one individually intersects with every single plane. Now, as we get further into this, it will become clear that we need to clean up that list a little bit. Actually, it's probably easier if we use the param viewer. So you can see from this that we have 90 branches, which is way too many, and that's because we have 45 here, and so we have 45 times 2 B-reps, so we're getting 90. And what this is a lot of junk, right? There's going to be a lot of these empty planes where it doesn't actually intersect the B-rep, especially in this guy over here is this branch 1. And so this guy, there's just a lot of empty branches in that tree. So we're going to clean that. So we get down to 36, and now you'll see that this guy here, which is these first, well, not first, but the tree branch number 1 only has 5 floors, and so that's great. So that's nice and clean. And then we're using trim tree to cut it back down to just 2 branches. So we have all of the floors for tower 0 in 1 branch, so 31, and all of the floor plans for tower 2 in this 1 branch here, so the 5 floors here. Now, the way this is spaced, we are going to get a floor plan here at the roof, at the top of the building. And so we're just going to use, because we're curious, eventually we're going to build up a dashboard here. This looks really confusing and overwhelming. Good God, I don't even... Hold on 1 second. We have screwed something up. Stand by. Okay, I have no idea what happened. Somehow I accidentally copied and pasted a component 30 times. But basically, if we come over here, what we're going to do is build up a dashboard here. That gives us the height of each tower, the number of floors, the total area, and the average floor area. And so in order to get the correct number of floors, I'll show you how we're going to calculate that. But basically, we first want to clean our data and make sure that we have no empty branches and that we are not accidentally including the floor area of the roof. So we have culled out well, first we've reversed the list. So the roof would have been the last floor, and so we've reversed the list so that the roof is now the first floor, and we've culled out that 0 index. So the purpose of this tutorial is not really to go through those. So we're going to sort of keep on moving. But if that's confusing to you, you can take some time and explore this. Just look at the trees and how we have gone from one tree structure down to another one and then removed one item from it. So here we are just going to preview those lines, so that's nice. We have taken the area, so if these are our floors here, we have taken the area of each one, and we are basically just pulling out some information from that. So first we can take these curves here, and maybe it'll be easier. These are just the same curves, but for simplicity's sake, you can see them here. We can even hide these guys. So by taking their areas, we get a point in the center of each one. We can take those points and sort them by their height, which is this z value here. And this will put the lowest value first, and it will go up until the highest point here. And all we've done there is again reverse the list and taken the first item. So now we're taking the highest point, and that effectively gives us the height for each tower. We can take the entire list, which is all of the heights, and just take the length of that list, and that will tell us how many floors are in each tower. And again, this is the reason that we needed to clean the tree back here, because if we were to count every item, here in this list, without cleaning it, we would get and we can just do this really quickly. I guess clean tree, oh, okay. Maybe that was unnecessary. Clean tree gets rid of the these empty branches anyways. So maybe that was an unnecessary step. All of these guys here where our planes are not intersecting our building. So maybe we'll just skip over that. But I'll leave it in because because it's in there now and we're recording. So anyways, having cleaned that, we have the correct number of items. So that's great. We can also take the area of each floor plan and we can use this mass addition to add them all together. And that will give us the total area for that tower. We can also, rather than doing that, we can average the area of each floor plan, and that will give us an average floor area. And so this is just a very simple way sort of to demonstrate in building up a dashboard how we can get some different values that we're interested in measuring. For your projects, you are probably looking at something more advanced like daylighting or shadow casting in a park or who knows what you're doing. But it should be probably something a little bit more interesting. But in an office where you're working every day, calculating floor areas is super important. So what is this mess over here? Well, this is basically just a bunch of code that's repeated over and over. And all we're doing is building up a dashboard. And unfortunately, building a dashboard a lot of times involves this sort of cutting and pasting. There's probably a slightly cleaner way to do it if you turn some of these into a component. And again, any text that you want, or any portion of the script that you want, you can always just cluster it like that. And if you right-click, you can turn on Preview Contents. And so this guy now, I guess it's an open question whether this is any cleaner than what we had before, but it would be one way. You could conceivably cluster, each portion here and then just copy and paste the cluster rather than copying and pasting your entire code. But I've left it exposed so that we can walk through it. So what we're doing, we have two towers, and so we've flattened the list so that we get each item individually. And so we will pull out this 0 item for tower 0, which is this guy, and the 1 item for tower 2, which is this guy. And so if we look at the value, 580, in whatever units our Rhino space is in. So we've used concatenate, which is just, again, base Rhino, just under sets, under text here. You can basically just add in text, so height here, concatenated with 580 from this guy, concatenated with feet, gives us this nice height equals 580 feet. Now we need to place that on the screen, so we're going to use this human tool, render text to screen, which can be found over here. And that takes the text, and it takes a location, and a font size, and a color, and a font. So because we know that we're going to be repeating this over and over and over, we're basically going to repeat it for our header, then for each one of these items, and then again down here for tower 2. It's really important that you just set up some global variables like this. And that way you can, for one, if for some reason you decide that you want to replace a slider with some other means of calculating your header size, maybe you want to make it proportional to the number of towers you have, or who knows. The important thing is that you've connected it into a component so that you can easily swap that in and out, because this color is going to go down and connect to 10 different inputs, and if you wanted to change that swatch, so maybe instead of a color swatch you wanted to use like an HSV color that let you define it. Again, these are all base Rhino under display. Rather than reconnecting it 10 times, you could just reconnect it into this color component and quickly update everything. Also, and we went over this way at the beginning of class in the explanation of the template file, by using the hidden wire display over here, you can keep this script a little bit cleaner and more manageable, so that it doesn't look like this with just wires everywhere. So here we've set our single font family for the headers. So this is bold. We're using this for the header values. We're using regular Arial for the body. We have our font color. We have a header size. And again, we can, because we've been nice and clean in how we've attached all of those components to a single input, we can control it once, like so. We have a font size for the body, and we've also got a leading value, which controls the spacing. Leading 1 is the spacing between the header and the body, and leading 2 is the spacing between the lines of body text. So all of those guys are just copied down here so that we have control over the size, color, and font. Now, the location is a little bit trickier, but again, we want to be really systematic about it. And we want to build it up in a way that allows us to have control. So this guy here, this is a little counterintuitive because it's actually going to use dimensions based on your screen, even though we're putting them into a point container. So this location, it wants a point, but it wants values for that point based on your screen. So we're going to give it an x value, which determines how far sort of in the left-right dimension. And we're going to give it a starting value here for the y component, and that'll define a point. What we're going to do then is define each following value. So this is our header. This is tower 1. Ugh, if I click over here, Jesus. So I can turn that on or off. When I come down here to make the height 580 feet, everything is the same. Well, I've got a different size. I've got my body text size, the same color, and I've got my body font. So when I define the point here, I'm going to copy down the x value because I want these all aligned. So they're left aligned because they all have the same x value. And my y value, I'm going to take the y coordinate from above, and I'm going to subtract this leading value here, like so. And then when I make my next value for the number of floors, I just keep repeating that process. So I take the y value for this guy, for 580, and I subtract the leading again, and I get a slightly lower value for floors. And you can see we're just repeating that over and over. So this looks complicated because it's a lot of components and it's a lot of wires, but really it's the exact same thing. It's the same render text to screen component with the same inputs, and all we're doing is updating the y value every time so that it drops down, drops down, drops down. So this guy here, these are all the Tower 1 dashboards. So, ba-boom, like that. Turn those on and off. And all I've done is copied and pasted those down here to get our Tower 2 dashboards. And the only difference here is that we've specified a different starting y coordinate for Tower 2, but it's the exact same logic. We're just bringing that down, subtracting the leading, down, 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 chaining those together. And so that way, it takes a little while to set this up. It is a little bit laborious, but it gives you a lot of control. So again, if I decided that I wanted Garamond italic, boom, now I can have italic font, and I decide that that leading is not quite what I want. I need a little bit more leading there, and my dashboard down here needs to be a little bit lower. Boom, I've got great control over all of that. The other portion of this dashboard is this background here, which is nice because I can see through it like that, and I think that's pretty cool. I think that's pretty. You'll notice it's a little glitchy, and that's because Rhino and Grasshopper are trying to figure out the z-depth, which is just a fancy way of saying what goes in front of what. And so it's trying to figure out how to make this dashboard appear in front of the geometry. So if you are trying to make an animation where this is moving around, this may be a little bit glitchy. But what you guys are more likely doing is setting up a single view for your building, your iterative model. And these guys will be changing, but the location won't be. And so this will probably not flicker like that. So the background here, we're using this component, also Human Tools, Render Mesh to Screen. And what we're doing there is creating a plane in RhinoSpace. And we are just rendering that plane to the screen. Similarly, the plane needs a point. So this guy here, we've just defined a point that is in pixel space. And it has, I'm not actually changing the value of the size of the dashboard, I'm just changing its location here. But similarly, I could make it smaller or taller or more narrow or wider. And there's a color here. And so what I've done is lowered this alpha value to make it transparent. So it's black. If we made it totally opaque, it would be a little confusing there. So we've made this something like that. We're still getting, it's a little glitchy. It's not perfect, but it will work if you just futz with it until you get it to look the way you want it to. We could probably, yeah, so text to screen does not have that depth component. This is the Z depth that I was just talking about. So if you wanted to, you could set this to a really low value. And what should happen is that these will now appear in front of it. But because that's hard, that makes it hard to read your text, we are instead placing this really, really high. Oof, apologies. I will mute my computer. And so now the geometry appears behind it. Okay, so that's really it. It's a lot of wires and a lot of components, but the base script, I hope, is exceedingly simple. How we're cutting those floor plans. And this guy is relatively simple. Again, it's just repeating several components over and over. Again, we'll go through this in class, so hopefully by the time you're watching this tutorial, it's the second time you've seen it, and it will be even less confusing. Okay, great, thanks.